On this question, they give us a function. They want us to find absolute max and min. How do we do it? Well, we start with the derivative. No surprise there, huh? Bring that down. Lower the power by 1. Bring that down. It's at 180 and 6196. X. And then that just goes to 0. And we set that equal to 0. So step 1, f prime of x set equal to 0. Solve for x, and those will be your critical values. That's how we find critical values, right? Where the derivative is 0, right? Because you know if you have a graph, right, at the top and the bottom, if you're on a roller coaster, you're flat, right? These are wheels here. At maxes and mins, at high points and low points, the derivative is flat. The slope, remember, the derivative is the slope. So the slope is flat at high points and low points. We're trying to find high points and low points. So you set the derivative equals 0, find those x's. Those are critical values. Those are candidates. They may be the highest and lowest points. We'll also need to check at the very end, we'll also need to go back and check the left edge, which is right here, and the right edge of the interval. You need to check critical points, left edge, and right edge. All right, so let's finish solving this. How do we solve this? Well, let's factor out 4x. Use your calculator. 4x times x squared, go back 4x cubed minus, is it 49, I think? 116.36. Yeah, yeah, that's right. So that'll go there and it'll go back. Use your calculator if you're not sure. Okay, so we factored it, but we're not done. Remember how to factor x squared minus 49? X times x. Remember, it's just FOIL, but there's no OI. It's just F and L. Front times front is front. Last times last, 7 times 7. One's positive, one's negative to make negative 49. You see, where's the OI? Well, it's 0 because plus 7 and minus 7 make 0, so there's no middle. So there's the factorization. Let's set each part equal, I guess. Let's set each part equal to 0. Each part that has an x, so 4x that has an x, or x plus 7 is 0, or x minus 7 is 0, right? Every part that has an x can vary, has a variable, it can vary. So any of them can be 0. If you have three things multiplying to be 0 and they all have an x in them, then they all could possibly make it 0. If any one of them is 0, when you multiply all three together, it'll be 0. So the first one could be 0, or the second one, or the third one, and they'll all multiply to be 0. So solve each of those. And so this one's easy. Divide by 4. So x is 0. They're all easy, huh? Move this over. -7. And move this over. +7. So those are our three critical values. We found those are places in the middle that could possibly be a highest or lowest point. The other options are the left and the right edge. Okay. Oh, yeah. And yeah, I'm going to tell you what that O was. I just said, so step 2, um, make a table that's going to have X and f of X. And what you're going to put is the left edge, the right edge, and you're going to put all crits, critical critical numbers within the left right bounds. So in other words, what we're doing on this question is they're saying, hey, this is some function. We want you to find the highest and lowest point this function gets to between -6 and 15. So notice if you graph, we're not going to graph the whole thing, but -6 to 15. I don't know what the function is. Maybe it goes down, up, whatever. We don't know what's the highest, what's the lowest it does between -6 and 15, right? -6 and 15. So to do that, you got to make a table and find, these are the y values, right? Remember, y values are our function values. So I'm going to plug in. So let's do that over here. Let's make an x. Oh, here, let me make an x and a function. And this is f of x or y. Whoops. What is f? What's my original fx function? X to the fourth minus 98x squared plus 6. X to the fourth minus 98x squared plus 6. Is that right? x to the fourth minus 9x squared plus 6. Yeah. Okay, that's my first function. And I'm going to plug in the left and the right. So x equals the left and the right. Negative 6, positive 15. Negative 6, positive 15. Okay. Now, all the critical numbers that are within the bounds. So x is 0. I'm grabbing these critical numbers now. Not that guy. X is positive 7. Why not that guy? Because this is outside the bounds. Negative 7 is further left than negative 6. Remember, we're going from, if you did a number line, would that help? If you did a number line, they told us to go from negative 6 to positive 15, right? This was the left edge and the right edge. They want to know the highest and lowest value the function takes on from negative 6 to positive 15. So, so therefore, negative 7 is over here out of bounds. The other ones are all good, right? The 0 is right around here. The 7's right around there. They're good, the 0 and the 7. But the negative 7 is out of bounds. He's not within the range we're looking at. All right. So now what do? We take this value and we just plug it in. So I'm going to go to Desmos and I'm going to type that in, x to the fourth minus 98x squared plus 6. And I'm going to plug in negative 6 first off. Negative 6. And so here we go. So negative 6 to the fourth minus 98. And then what is it again? We're plugging in negative 6 squared plus 6. Here it is. When I get negative 2226, negative 2226. So y equals negative 2226. Gets to the next one. Now we're going to plug in 15 to the Desmos function, to our original function. 15. 15. Whoops, not 15. There we go. 28,581. 28,581. It's a big number. Now plug in 0. That should be easy. Yeah, it's just going to be 6, huh? 6. Yeah, it's easy. Could have done that by hand, huh? And finally plug in 7. So we're just checking the left edge, the right edge, and the critical values in the middle to find out who's the biggest, who's the smallest. 7. There we go. What do we got? Negative 2395. Negative 2395. Negative 2395. All right. Who's the biggest? Well, this guy. He's the max. Who's the lowest? This guy. He's more negative than this guy is, huh? 2300 negative is more than 2200 negative. All right, there's the max, there's the min. What they want for us. Yeah, minus 2395. Yep, we got it. Max is 28,581. 28,581. We got it. So again, we checked over the interval. We chipped to the left edge, right edge, and the two critical, well, 2 out of 3. We dropped that critical because he was outside the range. So that if you check the critical points and the left and right edge, you'll find the highest point. It's amazing. We can find the highest and lowest points of that function without ever seeing the function. We just know it because derivatives are powerful. Calculus is powerful. We just check the left edge, right edge, the critical values in between because the critical values are going to be the highest and the lowest. Those are the only places it could take the highest and lowest values, those and the endpoints. So there we go.